Okay, we have written another integral. This one's from the Swinbee 2019 problem 5. We have the integral from 0 to 1 of x, arc sine of x squared over the square root of 1 minus x to the fourth dx. Okay, now to get started with this, the first thing I notice, just having arc sine here in the numerator. Now, if we just had arc sine of x, the derivative of that's going to be 1 over square root of 1 minus x squared. Really similar to this. And the thing that's going to work, I think, is we have x squared here. So instead of having an x squared here, we should have an x to the fourth here. So what I'm thinking is let's use this and just do a u substitution and see what happens. So we'll make the u equal to arc sine of x squared. And I'll go ahead and take a derivative here. So for du, first we're going to have 1 over square root of 1 minus this squared. So that gives me this x to the fourth here. But then we need the chain rule on this right here. Taking the derivative of x squared, that's just going to give me a 2x here in the numerator. And we'll add on this dx. And now what we have here for du is like really similar to everything else here. We just need this 2 right here. So what I'll do is we'll just multiply by a 2 here, and I'll multiply by a half up front, so I'm not changing it. And then we can just go ahead and substitute. So we'll have this 1/2 in front. We need to update our bounds. So first plugging 1 in here, 1 squared is just 1, so arc sine of 1 is going to be pi over 2. Then taking 0, plug 0 in here, arc sine of 0 is just 0. Then the whole integral is really just going to clean up because this is our u, so we're integrating u, and everything else is du. So just like that, we can go ahead and integrate this. We're going to have 1/2 in front. Integral of this is going to be u squared over 2, and we just need to evaluate from 0 to pi over 2. First, we can multiply 1/2 times 1/2, and we can have this like 1/4. Plugging pi over 2 in here, we're going to end up with this is going to become pi squared over 4. Then minus the second part, evaluating at 0. You plug a 0 in there, everything else is 0. So putting this all together, for my final solution for this, we just get pi squared over 16. Okay, there you have it. Really quick and easy from Swinbee 2019. Thanks everyone for watching. Have a good day.